Hi Year 11, welcome to today's lesson. Before we start looking at our new biome within the Living World topic, I'd like you to have a go at completing the Do Now questions. The colours represent the difficulty. Green is from last lesson, orange is questions from our topic, and red is from our previous topic, looking at natural hazards. So have a go at those writing into your book, please. You can pause the PowerPoint now. So hopefully you've had opportunity to work through those questions. I'm just going to go through the answers now. Can I please remind you that if you've got any of them wrong, can you please correct them, preferably in a green pen into your book, so we can see which questions you're getting right and which ones you've got wrong. Right, so question one, name one local and one global effect of deforestation. I've said the local effects here are loss of biodiversity and economic development, and a global effect is climate change. Now again, with some of these questions you may have different answers. That's not a problem. If you know you've got them right, give them a tick. I'm just giving you here some examples. Question 2 says name one positive effect of deforestation for Malaysia. I've said economic development, but you could also have something like renewable energy in the form of hydroelectricity. So again, give that a tick if you've got it right. If not, please correct it. Moving on now to the orange. Name one input and one output of the nutrient cycle. All right, the inputs are things that add nutrients like rainfall and weathering of parent rock, and the outputs are what take nutrients away. So we've got surface runoff and leaching. Question 4 says, give an example of a small-scale ecosystem. Well, the one that we looked at and focused on was the freshwater pond, but you could also have something like a hedgerow. These run along the sides of roads and motorways, and again, may not be the size of something like a forest or even a desert or a tundra, but they still have lots of biodiversity within them. Question 5, which plate boundary causes both violent earthquakes and large volcanic eruptions? That's the destructive plate boundary. That's where two plates come together, the continental and the oceanic subducts under the continental, and these create very, very large and violent eruptions and earthquakes. Question 6, what sea surface temperature is required for tropical storms to form? And that's 27 degrees. And one of the main reasons why tropical storms form where they do is due to that energy that's required from those sea surface temperatures. So have a look through, make any corrections that you need to do now. Thanks everybody. So within today's lesson we're going to look at the second biome, which is hot deserts. And hopefully by the end of the lesson we're going to identify the environmental characteristics of hot deserts. If you have a look at the two images below, I think these are probably traditional images of what we think deserts are. We might describe them as dry and sandy landscapes. Now, this description may be basic, but actually gives us a little understanding of the characteristics of what we might find here. Now, in reality, they are much more complex as we look a little bit further and deeper into them. Rainfall, as we probably know, can be very low, but there is often just enough to support the different types of plants and animals that you might find here. And you can especially see that in the bottom right-hand photograph, where we've got a number of different plants which are growing within this desert region. And you know, they're not just sandy, but they're more complex than that. The landscapes have got rock and gravel which has been worn down by sort of strong and dry winds, and even the occasional flash floods. Over 1 billion people live in deserts, so they are home to a significant amount of the Earth's population. And people find that there are lots of challenges living here, but there are also opportunities. And we're going to find out a little bit more about deserts as we go through this topic. But as I say, today is just to focus on those characteristics. What do we find here? What is the relationship between the biotic and the abiotic? So to start with today, it's thinking about that word characteristics, something we looked at when we started our tropical rainforests topic. I'd like to study the photograph that I provided. We can see here a typical image of a hot desert. I'd like you to write down 10 things that you know about this type of ecosystem. It might be about the temperature, it could be about the animals, it might be about precipitation, it could be about the plants that are found here or the humidity. Just write down 10 things that you know about this type of ecosystem. One of the things that's really important for geographers is to know about location and being able to describe the distribution of where hot deserts are found along the Earth's surface. Now this is generally a 2-mark question, and this might come up at the very beginning of your Living World exam. I'd like you to have a look at the statements below. I've provided you with 4. There's also a map. What I'd like you to start to think about is where are deserts found on the Earth's surface? So there are 2 sentences below which are correct, and there are 2 sentences which are incorrect. I'd like you to read through them, and using the map below, I'd like you to write down the 2 correct statements into your book. You can pause the PowerPoint now. So hopefully by using the map below, you've chosen the 2 answers that I've highlighted in red above. The first one is that hot deserts are located along a band 15 to 30 degrees north and south of the equator. And the second is that hot deserts are located in North Africa on the west coast of North and South America. They're found in other countries and continents as well, as you can see the Great Victorian in Australia, or the Thar Desert in Asia. Also the Atacama, which is in South America. But you can see that all of those deserts are found within that 15 to 30 degree band. And we're going to look at the reason why they form there later on in today's lesson. If you've got those wrong, just make sure you've corrected them now into your book, please. You can pause the PowerPoint now. So thinking about the distribution of hot deserts, what I'd like you to have a go at doing now is writing a small paragraph into your book which describes the distribution of where hot deserts are found on the Earth's surface. To help you do that, you might want to use some of the pointers below. So I've provided you there with CLIBS. We've used that a number of times, and we did use that when we described the distribution of rainforests. You might want to use continents, and you could also use lines of latitude to help you do that. I provided you with a sentence starter to get you thinking about where they're found, and you can also use some of the sentences that we looked at previously. So just in your book now, have a go at describing the distribution of hot deserts on the Earth's surface. So we need to understand why the deserts form between that band of 15 to 30 degrees north and south of the equator. Now, atmospheric circulation plays a really important part in this, and we've actually looked at this in a number of our different topics. Atmospheric circulation is the reason why tropical storms form where they do, and why rainforests are found along that band along the equator. You can see below that I've provided you with 6 sentences. What I'd like you to do is to try and put them in the order of which you think are correct, so that you can begin to explain the formation of how deserts are found where they are on the Earth's surface. I've started off by giving you the first one, and that is at the equator, the ground is intensely heated by the sun. This causes the air to rise, which creates low pressure zone on the Earth's surface. Just to remind you that low pressure is where we get very unsettled wet weather, and high pressure is where we get very dry, very hot weather. That might help as you go through choosing in which order the sentences need to be put. So just have a go now. You can just write the numbers into your book, because there's a challenge that I want people to have a go at doing, where you may think about those sentences or small paragraphs. You can pause the PowerPoint now to have a go at completing this task. Each of the sentences now is in the correct order, and I'm going to just talk through and help you understand the formation of why deserts form where they do. So we've already been through the first sentence, that at the equator, we know that this is where the sun is most intense, and the ground here is heated very, very quickly. This causes the air to rise, which again creates a low pressure zone on the Earth's surface. As the air rises, it cools and forms thick cumulonimbus storm clouds. And this falls back to Earth as rain, creating tropical rainforests. As we know, rainforests need significant amounts of rain, and at this point on the Earth's surface, we get a lot. What then happens is that the air separates and starts to move both north and south towards the poles. And as it reaches about 30 degrees north and south, the air cools. And as it cools, it sinks towards the ground, forming the subtropical high pressure zone. Now, as that air sinks, it becomes warmer and drier, and this creates an area of little cloud and low rainfall, the characteristics that we maybe looked at the very beginning in that image, and this is where deserts are found. And the Hadley cell is then complete. The air completes the cycle and flows back towards the equator as the trade winds, and that cycle will continue, and that is why deserts are found where they are. Now, I want you just to make sure that you're familiar with that. I know that we've looked over it as classes together, but there's just a little bit of a challenge to get people thinking in more depth about what's happening here. What I'd like you to have a go at doing is drawing the image above of atmospheric circulation. And then I'd like you to annotate your image with simple sentences from the right hand side to try and explain how deserts are formed. If you'd like to have a go at the challenge, pause the PowerPoint now and try to complete that task. Along with being able to describe location as geographers, another really important skill is to be able to accurately interpret climate graphs. And we're going to have a go at doing this by having a look at figure A. So figure A describes the climate of In Salah, which is in Algeria in the middle of the Saharan desert. You can see by looking at that climate graph that we've got both temperature and rainfall which has been recorded. Temperature, as you can see, is a line graph, and we've got both max and minimum temperature, so you can see the range of temperature throughout the months. Rainfall is as a bar chart, and you can see that below in the blue bar chart. What I'd like you to do is, using that climate graph, I'd like you to have a go at just trying to complete the 5 questions that I've provided you with on the right hand side. Make sure, please, that you're accurate when you're maybe trying to state the temperature or the amount of rain which falls within that area. So pause the PowerPoint now and use figure A to complete the questions, or the 5 questions which have been provided for you. Now, I don't think sometimes a climate graph alone gives us a true understanding of what the conditions must be like within these desert areas. So what I've done is I've provided you with a climate graph of London so that we can compare the two. You can see below there's also a challenge which has asked you to state that comparison. Are there any similarities? Are there any differences? Now, to do that, you need to have a look at both temperature and precipitation. But just having a look at the 2 climate graphs, we can see that London receives far more rainfall than In Salah in Algeria. And we can also see that the temperatures are far hotter. But there are still some similarities. We can see that July and August are the hottest months, both in Salah and in London. We can also see that in November, London receives some of the highest rainfall. That's the same in Salah in Algeria, even though it may be significantly less. So just using now data from the 2 graphs, if you'd like to have a go at the challenge, please try to compare the 2 climates that you can see on the graphs in front of you. You can do that straight into your books. So pause the PowerPoint now if you want to have a go at that task. So we're coming on to the main task now for today's lesson, and today requires you to do some reading for purpose. What I've done is I've provided you with an article from the National Geographic magazine, and this article identifies the characteristics of hot deserts. And whilst you're reading through the information, what I'd like you to try and do is complete the table below. You've got climate and temperature, soils, plants and animals, and physical features, and you can complete this table by adding in bullet points. If you want, you could print out the National Geographic magazine article and you could highlight it. That could be something you could do as an alternative. If you've done that and you feel that you would like to have a go at the challenge, you can then do this to enhance your understanding of the characteristics in hot deserts. What I'd like you to do is use the internet to research further the characteristics of a specific desert. So you might look at the Thar. You might look at the Great Sandy Desert in Australia. You could look at the Atacama. And what I'd like you to do is to add specific information to the table in a different coloured pen. Thanks very much, Day Year 11, for listening and completing today's tasks. What I've provided with you is a Google Forms quiz. If you could have a go answering the 6 questions and then submitting that, that would be absolutely brilliant. Thank you very much, everybody. Bye-bye.